Here is the solution for that one. You'll notice they made a table of values and then they say plot these points. Unfortunately, they didn't do. Sometimes they fail to do this, don't they? They didn't actually graph the inverse function on here. So if I'll just take a moment, this negative 4 comma 4, the inverse will be 4 comma negative 4, so it'll be over here. Negative 1 comma negative 1 will stay the same. And then this point 1 comma 3 will become 3 comma 1, will be over there. And our last point 3 comma 2 will become 2 comma 3. And then if I join the points together, I'll even stick with the blue. So 1 there, and then 1 there, and then 1 there. Did I do that right? I think so. You see that neat kind of pattern. So sketch, we did that. Check. On the same is the inverse of function. So how do you know if it's a function? Well, the easiest way to tell is whether or not it passes the vertical line test. So here I'll make a vertical line and then I'll grab it and say, okay, so if I move this around, does it cross anywhere twice? Yeah, all through here. In fact, there it crosses 3 times. So the vertical line test says if I wave a vertical line through here, it should only touch the function once. So in the original one, yes, no problem. The original one is a function, but in the inverse, it's not a function. So the answer to the second part is the function no, and explain does not pass the vertical line test. It's just fine. State the domain and range of the function and its inverse. So I'll scroll down to the bottom. Oh, is it on the next page? On the next page, the domain and range of the inverse. The original one, the domain is from -4 to +3, and so look what happens here. Since the x and the y's are switching, right, this domain becomes exactly the same as this range, right? So this -4 is less than or equal to x is less than or equal to 3 becomes the exact same thing, but you would just substitute x for y, and now it's the range. And so also with the range of the original function becomes the domain of the new inverse image function. And that's what this states right here, right, is they switch the domain and range of a function and its inverse. The domain of the original function is the range of the inverse function, and the range of the original function is the domain of the inverse, so you switch the two. Okay, let's take a look at our second example here. Determine an equation of the inverse of y is equal to x squared plus 3. So y equals x squared plus 3. You notice that they didn't start off and say f of x is equal to, right? So we didn't have to do that first step that I outlined earlier in changing f of x for y. I think you'll find on the provincial exam, however, they usually start off with saying f of x equals to, and if that's the case at this very last step, you should say, instead of just having y, you should say f of the inverse of f of x. So I just want to get you into that habit of stating that answer using the inverse notation, this f -1 of x. Okay, but let's see what happens. They switch the x and the y right there. There they do the switch. And now they're doing the work of solving for y. So from line 3 to line 4, notice what happens. They do the square root to both sides, but you need to ensure the plus and minus sign here, because if you think of it, x minus 3 after it's square rooted, right? If it's y could have, like here, y could have been positive or negative, and when you square it becomes positive. So once you do the square root of both sides, that's where you need the plus or minus. It's like saying if x squared is equal to 16, x can be equal to either positive or -4. It's the same idea. So if this was a negative to begin with, after you square it, it becomes positive. So if we put those two in, and if we graph it, do they graph it? Sketch the graph? So let's check the next page. Sure they do. Okay, so here's our original, right? And here is the inverse, right? Is the inverse a function? No, it does not. Since the graph of the inverse does not pass the vertical line test, the inverse is not a function. So it's not a function. Okay, we can still graph it. We can call it a relation, right? It's still a relation, so we can say relation, check. Function, x. Not a function because it doesn't pass the vertical line test. Vertical line test is essentially saying for one x there's only one y. In this case, for one x there can be more than one y. Let's try the previous one here. Let's try the example that goes with it. Determine an equation of the inverse of that. I'm going to do this one with you. So the first step is, if it wasn't done already, to put it as y equals. So we'll just start with the switch the x and the y part. So instead of y, I'm going to write x is equal to negative y squared plus 4. Now I'm going to be solving for y, so I'm going to say x minus 4. I'll put minus y squared equals that. So I did two things from here. I subtracted 4 from both sides, so I got x minus 4, and I just wrote the y on the left hand side. Now I'm going to multiply both sides by negative 1, so I get y squared is equal to negative x plus 4. And now I'm doing the square root part, so y is going to be equal to the square root of negative x plus 4, and I got to do my plus and my minus part here. So we should sketch the graph of these two things. Well, first of all, if we sketch the graph of y is equal to minus x squared plus 4, you kind of already know that this parent function looks like this. Because it's negative, it opens downwards. Because of the plus 4, it's going to start at 0, 4. So my original function kind of looks like that, doesn't it? If we're going to be reflecting across the y equals x axis, if we're going to reflect across this axis, switch to red, this point is going to end up being over here. Right? Instead of 0, 4, now it's 4, 0. Right? This piece here, after it reflects, and also this point is going to be the same, right? So this part here is going to go like that, kind of. All right, and this here will also be common, so that part there kind of goes like this. Okay, so this, any point that's on that y equals x is going to be on the inverse function, and this 0, 4 becomes the 4, 0. Is the inverse a function? No, it's not. Okay, because it doesn't pass the vertical line test. I just want to also just reiterate, this part here, right, ends up going with this part here. So the left hand side here, maybe farther away from the y equals x line, goes to the bottom here because it's also farther away from the y equals x. This right one goes into that one over there. So that's example number 2. They do a nice little piece here. They'll notice that if you pick these 2 points, if you find the midpoint between them, so if you take the 2 x values and the 2 y values and find the average of the x's and find the averages of the y's, we get a midpoint of 3, 2, 3, 2. So the fact that this number is the same as that number means that it is on that y equals x. So it's just a nice little way of testing. So looking at example number 3 here, determining restrictions on the domain of a function. Alright, so here is our original function, y equals negative x squared plus 5, and they have it graphed for us nicely. And then they say sketch the inverse, and so they do go through all the work of switching the x and the y, and you get that plus or minus, and here is the inverse of that function. Now it says it does not pass the vertical line test, so it's not a function. But what we can do is we can restrict the domain of the original function so that we have so that the inverse is a function. So I'm just going to remind you here. I'll scroll down a little bit. If we kind of color code this, I'm drawing in red. So this part here of my original function corresponds with, remember that's like the part that's farther away, so this point here goes with here, and this is common, so that red part corresponds with this on the inverse. Okay, so if we restricted the domain of our original function, this is our original function, to x being less than 0, then this part of the function would disappear, and we'd only be left with the left-hand side, and then the inverse of that would now pass the vertical line test. So that would be a function. So one way to restrict the domain, to restrict it, is to say that on the original one, if we took this, y is equal to, if we said y is equal to negative x plus 5, but we restrict the domain and say x is less than or equal to 0, then only the red part would show up. And then on the inverse, we would get y is equal to plus or minus all that stuff there, and only this red part would show up. Okay, we would get just the minus part. In fact, over here we would get y is equal to negative times the square root of x minus x plus 5. The other way you can restrict it, and I think that's the way they do it first, if we say, what if we just draw the positive x values? What if we say x is greater than 0? So only the right-hand part stays, and thus this part stays in our inverse function. Those are the two ways. Let's try the check your understanding together, shall we? You know what? The announcements are going on, so I'm just going to pause here.